All right, so my topic going to cover the CXL switch. So thanks, Frank, for this opportunity to talk about XConn technology and the product we're working on. So um, first of all, I want to kind of introduce the concept of CXL switch. I think, probably everybody knows about it, but I want to take this chance to introduce why switch is important for this CXL ecosystem. So basically, we believe for the CXL to be something called scalable, right? Scalable means you can be small, you can be big, you can be, meet your need, right? Some kind of, let's say the AI computing system, their size is just small. They don't need so many GPUs, so many computing resources that can be small, or memory footprint in that case, right? But then there's also the very large model that going beyond the terabyte to tens or 20s or even more kind of for those kind of scaled of system. Then that pushes the limit to a much larger scale system. So the good thing about CXL is it will cover both small application as well as very large application. And this scalability is very important. And the CXL switch provides this scalability for the system. So think about every CPU or device, they can only have a limited number of the CXL port. But it'll be very hard for them to directly connect to each other, right? But CXL switch provide a more like a hub that enable to everybody to connect to it and then direct the connectivity between all these devices. So I would say, the switch would fan out to a large memory expansion, right, and pooling. So that's where our switch, the Xcon switch, has 256 lanes and total 32 ports. So that fan out of 32 port can enable a system to be very scalable to a larger computing node, right? So that's where the scalability means. So also the system architecture, if we, without a switch, you would have to go each node to node, kind of end-to-end connection. But once you have a switch, every device in this heterogeneous computing system go to the switch, and that makes the system architecture very simple, right? And very simple means you can be able to scale that system. Also, the computing getting to more like a fabric network. So we have seen a number of examples where a single node resource is just not enough to do all this computing. You want up to hundreds and thousands of computing devices all network together to compose of a fabric network. And the switch is the vehicle to getting there. So our switch also support this multi-level kind of switching capability and cascading of the switch to get to a computing node up to thousands of computing devices. So here in the bottom, I just put some pictures from the CXL consortium that kind of give you an example. At today we're CXL 2.0 switch, but we're getting to the CXL 3.0 or 3.1 switches in the next year or so. And you can see the scalability and the fabric network kind of being conformed, being enabled by the CXL switch. All right, so let me move on. So let me just briefly talk about Xcon's CXL switch. Xcon has the world's first CXL 2.0 switch. So that product number is called XC50256. And it is also essentially also a PCIe Gen 5 switch as well, because everybody knows the CXL is building on top of the PCIe technology. For this switch, we have 256 lanes, as you read it easily from the part number, and total capacity become 2 terabyte per second. So that's kind of combining all the lanes, all the ports, upstream and downstream all together. And this chip was taped out in 2 years ago. And we have the ASIC chip in our lab for a year and a half. We did a lot of verification. And so far, we have a lot of test data shows this ASIC has the lowest port-to-port latency, which is required for the CXL 2.0 memory pooling and sharing kind of application, right? And also the lowest power consumption per port, because we kind of, our chip design was just focus on this AI computing CXL switching market. So we are ignoring some other applications. That's why we be able to optimize our design to reach a very, very low power consumption. And because it has a large radix, one of the switch can already handle a lot of workload or design, right? So that kind of give an advantage to the system designer to use one single switch and do a very large computing node, computing design or architecture. The chip will be able to connect to, there are going to be total 32 ports. Each port can be by 8, but it can also be a by 16 port. And we support a CXL Fabric Manager, which is very important for the CXL 2.0 memory pooling and sharing, and also more important later for the CXL 3.0, 3.1 Fabric Manager. The chip we're designing right now can support cascading mode. Although cascading is being defined in the next generation, we already see a lot of demand for this kind of cascading feature, because our customer, they don't want to just have one single switch connect to a limited number of memory devices. They want to build a very large memory pool system to enable their application, and that can be enabled by the switch cascade. So this ASIC chip has been customer samples from last year and is still ongoing. And we are getting the production chip ready to go to production the second half of this year. So let me briefly talk about these CXL 2.0 applications. The one simple application is a memory expansion, right? So here is some very simple picture how this memory expansion can be enabled. Remember, our switch has a total 32 ports. If we use some port for the host connection and the rest of port all go to the CXL devices, for example, if we use the smart modulars CXL module memory devices, their capacity is going to 1 terabyte per device. So imagine in that case, you have you kind of attach 30 CXL devices. That memory expansion go immediately to the 30 terabyte. So that's kind of tremendously scalability to go to a very large memory footprint. If you attach more switches, that's going to be multiplied by how many switches you attach to it. So that's a very simple usage case we can see. Today's computing system can very easily take advantage of a switch and also the CXL memory devices. But I feel like, yeah, everybody's high interest. They don't want to just enable a single node memory expansion. They more want to work to do a memory pooling and even later to go to the memory sharing, right? And for this picture, which is again borrowed from the CXL consortium, you see these multiple hosts, H1, H2, right? They all connect to the switch through an upstream port. And on the downstream port, there's a number of CXL memory devices which form a bigger memory pool. So here I just put one switch here, but to build an even bigger memory pool, you can use cascading a number of switches which enable more ports and more attachment. And then another important element is the management or fabric manager platform. So this kind of system, today, our XConn as a company, we have been able to put together a solution that works with the shipping processor, which are CXL 1.1, and also the upcoming, server processor, which are CXL 2.0 in this year. Right. So I talk about the CXL memory sharing, right? And memory sharing actually is a very important application or very critical application for the future computing. So the idea of memory sharing is, if you look at the picture on the left, the host 0 and the host 1, through the memory pooling, they could allocate their own memory on the CXL devices through our switch, right? The same color kind of memory block means that goes to the same color host. However, in this case, the memory sharing, you could allocate a block of memory space that both host 0 and host 1 going to access. That's what we call the memory sharing. So at this stage, at CXL 2.0 stage, this kind of memory sharing can only be supported by the software, where the CXL 3.0 will really enable the hardware level kind of memory sharing. But even today, with this kind of software controlled memory sharing, there are already a lot of applications that can take advantage of that memory sharing. So MemVerge is our partner company. So they are specialized in the memory application, right? And they are already working on their software to enable this memory sharing capability. So the right side picture, I just borrowed some system architecture from MemVerge, which they are working on this project called Gizmo to enable the memory sharing. So again, at this stage, the CXL memory sharing is possible through the software. What we see the memory sharing that is important for the AI computing system is because the memory sharing is has a lot of advantage over the RDMA. For example, RDMA is one level much slower, much higher latency than the CXL memory. CXL memory latency is around hundreds of nanosecond, but RDMA going to be the microsecond, tens of microsecond. And also the memory sharing, that operation model is more like a load and store. So you don't have to transferring this data across the node, right, to go through a network. So that save a lot of energy, but also simplify your programming. Plus, CXL has its defined already, the memory coherency, they're going to give a lot of advantage for this memory sharing. With our switch, we be able to do this memory sharing to a very large scale. So in the previous picture I showed, 30 terabyte is very easy to get, right? And even more, you just add more switches. So some of these large computing, AI computing, they could take advantage by utilize, multi-terabyte of CXL memory, or even tens or 20s, 30s of terabyte of CXL memory to do the computing. And because everybody in this ecosystem bringing CXL together, right, that in the future, the total cost going to get lower and lower. So this kind of memory sharing through the CXL switch and the new software that enable memory sharing will really boost the AI computing system tremendously. Okay, so so this one I just want to tease a little bit on the future technology for the CXL switch and what that can enable. So in the CXL 3.1, that standard, that spec was published last year. With the 3.1, we are really seeing all these heterogeneous AI computing systems coming together to be united by this CXL 3.1 standard. So in this picture, you can see, all the CPUs, all the GPU accelerators, memory, and the DPU network card, right? And some of the new called, in-memory or near-memory computing devices, and even the storage devices, they can all get connected together efficiently by a CXL 3.1 compatible, ecosystem with a switch, connecting every component of this computing ecosystem. There is a lot of going on with AI computing, and for this hardware and all these spec, it's going to be available in the next year or 2-3 years. There are going to be more software work on this to enable this AI computing. For example, some of the AI computing models, right, to get all these data, kind of taking advantage of the CXL network, CXL fabric. That's going to probably get developed in the next 2-3 years. But we do see, CXL 3.1 has a lot of potential to really boost the AI computing system, to really kind of get the AI computing system architecture to the next level, to be lower cost, to be higher performance, higher efficiency. So there's a lot of potential, a lot of work ahead of us. And XConn being the pioneer in this CXL switch, we do have a roadmap going to have a CXL 3.1 switch and also the PCIe Gen 6 switch in the next year. And we're currently working really hard to get the silicon taped out, get our product sample to the early next year, and wish to work with everybody on this exciting new computing architecture and the system. Right.
Hey JP, can you check in your Q&A? There's a couple of questions for you.
Okay, so frankly, I don't know where to check the Q&A.
I'll read the first one to you.
Yeah, let me finish. I think that's
okay.
Probably my last slide.
Okay.
All right, so I'm also going to use this chance to talk about our current product. which we mentioned in the product page, the XC50256, which is the CXL 2.0 switch, and also the XC51256, which is a PCIe 5.0 switch only, right? So we basically seeing right now, it's a mixed kind of stage where you have CXL devices, you also have PCIe devices. And the whole industry is kind of transitioning, more like, the data center AI computing industry, they are transitioning from the PCIe interface to the CXL interface. But it still takes time to get that transition done, right? So at this stage, we see our product, these three usage case can be enabled by these current switch. So you could do a PCIe only, right? With some of the GPUs and the network card to use the switch to connect. And also you could do a CXL only. But more likely, there's interesting implementation where you have both PCIe and the CXL. You can also do this kind of design because our switch support a mode called a hybrid mode. The hybrid mode can operate, half as a PCIe or half as a CXL, or, you can program it to be, 1/3 to be PCIe, 2/3 to be CXL. That's totally software programmable. And we do see, this kind of flexibility will enable more design to get the hardware done. And then later, if there's any changes, you don't need to change the hardware design. You just need to change the software configuration to be able to kind of migrate it from the PCIe to the CXL or from the hybrid mode to the CXL, that kind of transition. All right, so this is my last call for action. I encourage everybody to join the CXL consortium to collaborate on the next AI and the computing system architecture with the CXL technology. And also, if you are interested in the Xcon technology, our switch, please, contact me, contact my team for a demo of CXL memory pooling and sharing. So here's my contact information.